Complex numbers are a super fun topic to learn about in Algebra 2, but they get even more exciting in pre-calculus when we mix them with the polar coordinate system.
In order to understand the form of a complex polar number, we must use the unit circle, and from this it can be determined that a equals r cosine of theta and b equals r sine of theta. And since we know that complex numbers usually take the form of a plus bi, we can substitute in these definitions and factor to get r times quantity cosine of theta plus I sine of theta, which is also abbreviated as r cis theta. If we'd like to convert from rectangular to polar, we must find both r and theta. R can be found using the Pythagorean theorem, where r equals c, and theta can be found using the inverse tangent of b over a, but you have to make sure that the angle you use is in the correct quadrant. Converting from polar back to rectangular form is a bit simpler. All you have to do is evaluate, distribute, and expand. Multiplying and dividing complex polar numbers can be treated in a similar way to logarithms. All you have to do is multiply or divide the r values and add or subtract the theta values, respectively. And of course, keep the base of cis. If we are doing repeated multiplication or raising something to a power, we must raise r to the n and then multiply theta by n. If we are finding the roots of a number, we should also add 360 divided by n to each theta value accordingly. This method is used to find even the nth imaginary root of any number. Thanks for watching, and remember, when doing problems with complex polar numbers, always remember to be real, even though they may not be.